Thank you very much for coming. This is obviously the first talk we've had at the East Anglian Centre for quite some time. We've got new chairs. Me and Berna over there are the new chairs of this local centre, and Chris has very kindly volunteered, shall we put it, to do the first talk of the new sessions. Obviously, I've got some general housekeeping stuff to begin with, so if you need any assistance, please see to be honest, anyone in this room that is doing the RMET stuff. We can pass you on to who we need to. Reason why I got you all to sign in is just for fire procedures. If there is a fire alarm, follow any emergency exit signs and meet outside the building. There are no planned fire drills that I've been told about, so we shall see. This is just some other RMETS general stuff, which if you've attended any RMETS talks before, just talking about Met Matters, the monthly newsletter, and some of the stuff they have inside it, really. And if you're not already an RMETS member, this is just a sort of description of all of the things that it allows you to get. So you get free online copies of our in-house journal. You also get full access to the 8 titles, including the quarterly journal and the International Journal of Climatology. Exclusive monthly members newsletters and events from the Society, such as this one, and discounts at conferences and paid for meetings and access to support grants as well through this scheme. So if you aren't currently a member and would like to be, please do sign up to be. And if you are in a university degree, which I know many of you are, these are some of the things that you can progress to in your career through RMETS. They are the official board for meteorologists, so they can offer certifications such as Chartered Met and Registered Met. These are for more when you're into your meteorology career, but are both very valuable in the industry. And I'll then invite Chris to do a talk on storm chasing in Tornado Alley.
Thank you very much for the introduction, James. So James and Murda, as James said, have taken over the local centre here. I ran it for a number of years until just before COVID, basically, and then it went defunct for a while. So it hasn't been running for about 4 or 5 years now. But the aim is to have about 6 talks every academic year. So this is the first one. And then we'll give you some information about the next 2 that are coming up before Christmas, and then there'll be 3 after Christmas as well. So especially for you that are students in the room, if you're interested in meteorology and a career, these things go on to be really good ideas for networking. So obviously most of you in here are either students or people that I know, so you can come to me anytime and ask about things. But when we have further talks over the next few months, if you come back to these meetings, do take an opportunity to introduce yourself to the speakers and to do some general networking, because obviously at some point you'll be graduating and you might be interested in a job in meteorology, and you never know who you might have met at one of these talks, and it becomes a talking point for an interview and that kind of thing. So I definitely encourage you to kind of engage with the RMET SOC, and if you haven't heard much about it, there is more than just this center. The RMET SOC also has a national center. As James said, you can become a member. There's a student rate for membership, and you get access to a whole bunch of online journals as well. You can get those online journals through the library too, so especially for those of you who are second-year students who will be doing a dissertation next year, it's a good idea to have a look through some of the RMET publications, because there's a lot of good weather research that goes on in them. So definitely take that opportunity to have a look and engage with all the RMET stuff. There's also plenty of other centers that are doing similar to what we're trying to do here in East Anglia across the rest of the country. And they do live stream some of their talks and record them as well. So there's actually quite a good bank of talks that have been given about other subjects. So if you kind of like this idea and hearing a bit more about weather, then you can go back and look at their sort of history on their website and click on various talks and hear more about them. But you didn't come here to hear me drone on about the RMET SOC. You came here to hear me talk about storm chasing, hopefully. So basically, as a youngster, I loved the weather, knew I wanted to be a weather weatherman when I grew up. There's even something from a primary school thing where we had to write about what we wanted to do when we grow up, and I put on it that I wanted to be a weatherman. So, and I remember distinctly in year 1 or 2, the local TV meteorologist came and gave a talk at my primary school, and I went up and got his autograph afterwards and everything. Believe it or not, that dude is still on TV even today. He's been in the industry for like 60 years now, so crazy. So anyway, when I got old enough to be able to kind of get in my dad's pickup truck and drive around, I decided that I wouldn't wait for the storms to come to my house anymore. I would go and look for them instead. So it started off with a disposable camera in the mid-1990s, driving around my area, taking pictures of clouds and trying to get my dad's car underneath as much heavy rain and hail as I possibly could. Thought I was a bit of a weirdo because nobody else around me liked to do that sort of thing. And so I went off to university and realized that actually I wasn't the only nerd that did that, and there were quite a few others. And so when I did my master's degree in Mississippi, they actually had as one of their field courses a storm chase into the Great Plains. So I went on that 3 times with Mississippi State University. We went out in big vans. The instructors gave weather briefings every morning. And it was basically for Phil and Kathy who are here. Hello, Phil and Kathy. Raise your hand, Phil and Kathy. These are storm chase celebrities here. They've actually been storm chasing more than I have, I think, in their lives. So it's kind of them to come and listen to me talk about something they probably know more about than I do. So, but anyway, so basically, I went on these storm chases with the university and couldn't get enough of it, so decided that I would go out and do them on my own as well. And that's kind of what I'm going to talk to you guys a little bit about today. I haven't been a very successful chaser, I'm not going to lie. Not seen that many tornadoes. In fact, we've got one other storm chase celebrity that I know of in the room, and that's Dan in the back row there. And so Dan, Kathy, and Phil have seen many more tornadoes than I have, so I'm sure if afterwards you want to hear about what it's like actually seeing a big tornado, then talk to one of them. But what I'm going to tell you guys about today is why the Great Plains is so unique. There isn't really anywhere else in the world where there is a significant tornado threat at roughly the same time every year through about a 1 or 2 month period, and you can literally go there on a holiday for 2 weeks and drive around, and you're going to see something. You might not see a big tornado, but you're going to see some fantastic clouds, and I've been lucky enough to see those at least, because you won't miss some weather if you go out there. So I'll explain kind of why that is the case. So basically, the structure of this talk is, where would you go? When would you go? What would you want to take with you? And I'm going to leave you guys with a little bit of a basic understanding of why, as I say, the Great Plains is such a unique place in the world for these big monster thunderstorms, which I will define a little bit more in just a minute. So, that didn't work. That is what I wanted to do. We're going to start by saying, well, where do tornadoes occur? So this is a funny map that I found online a bunch of years ago, and it was from a printed atlas of the world at one point or another, some encyclopedia showing where tornadoes occur around the world. So all the orange areas there are places that we thought tornadoes occurred around the world. This was probably, well, certainly that map was made well before the mobile phone era. And what we've realized now is actually tornadoes are pretty much form anywhere around the world. And there are lots of places that see waterspouts and tornadoes pretty regularly through the year. Most of the time, they're not the big, devastating tornadoes that we see in the Great Plains. There are a few other places in the world that do occasionally see those types of tornadoes. Bangladesh is one. There's a few spots across Europe where we occasionally see some larger tornadoes, but really, as I say, the Great Plains and Tornado Alley are the only place that really see them on a regular basis. So this is a rough map of Tornado Alley. It's not perfect, but it gives you an idea of the kind of area that I'm going to be talking about. So it's northern Texas, Oklahoma, parts of Kansas, Nebraska, up into the Dakotas, parts of eastern Colorado. Eastern Colorado is a really weird place. When I say Colorado, what do you mostly think about? Probably mountains. Well, actually, the eastern half of the state of Colorado is just a flat prairie land. And it's one of those places in the US where if you're driving on a road, there'll be signs that say there is not another town for another 110 miles, so you need to make sure your car's filled up with petrol. It is very barren out there. One day, were you with me the time we stopped on the car den in eastern Colorado, and we got out and we just put our tripods in the middle of the road? Yeah, I think, yeah, it probably was, yeah. And we took some beautiful sunset images, but we just had our cameras plopped out right on the middle of this like highway in Colorado, and we were there for like 30 minutes and didn't see another car the whole time. So it's just a very desolate area. But the Great Plains are awesome from that perspective because the horizon is generally flat. There aren't many trees out there, and you can just see for miles. So a few more maps to show you before I move on. So we're talking about Tornado Alley, which is this sort of central part of the United States, part of the Great Plains, which runs up through the central part of the US. But this map shows us tracks of tornadoes over quite a few years. And you'll see that Tornado Alley is actually just basically the western edge of the zone in the US where tornadoes are pretty common. So another place where we see a quite intense area of tornado activity is across Mississippi, Alabama, and southern Tennessee. And then if you go up into sort of northern parts of Missouri and Indiana and Illinois, then there are also quite a few tornadoes up there. In fact, one of the most famous tornadoes ever was known as the Tri-State Tornado because it moved all the way across Illinois, Indiana, and into Ohio, all in one track without leaving the ground. So pretty amazing. But actually, more deaths occur in this part of the United States from tornadoes than anywhere else in the US. And for the students in here, does anybody want to take a guess at why that might be the case? Why are there more deaths in this sort of area of the US than there are out here? Zach?
More populated?
Yeah, it's a denser population in the southeast. Also, there are a lot more trees in this area, so there's usually more debris flying around in a tornado as well. And there are a higher proportion of nighttime tornadoes in that part of the US as well than there are in the Great Plains. So all those factors combined actually mean that this part of the US is actually the most dangerous place to be around a tornado, whereas the Great Plains are better for chasing because it's very rural and you can see for a long way. And you get these big tornadoes that you get good visibility of. So this is getting a bit old now, but I've left it in mainly for the stats that are associated with it. So it's just to show that most of the tornadic activity in the US occurs between the two mountain ranges, the Rocky Mountains and the Appalachian Mountains. So you've got the Gulf of Mexico here, and then there will be a slide in a minute that I'm going to show where I kind of tell you about the air masses that are associated with the air that generates these tornadoes. But basically, you've got warm, humid air funneling up in between the two mountain ranges, and that's where we see most of the tornadic activity. But the sad thing about this graphic is that if you look up in the top right, you might not be able to see it too well, but there are 2,601 tornado tracks on this map over that 55-year period. This is only looking at what we call EF 3, 4, and 5 tornadoes, so the kind of biggest tornadoes that are recorded. So there were 2,600 during that period that were plotted, and they were responsible for over 4,000 deaths, so over a 55-year period. So unfortunately, that's the downside of going out and doing some storm chasing, is that this kind of stuff is affecting the people's lives who live there, and you do have to be a bit respectful of that and understand that you might be excited about seeing a tornado, but if it's going through the town, it's wrecking people's lives. So there is a bit of a kind of weird feeling about being out there and looking at something so devastating. So that's kind of where they occur. And this is a funny map to finish this on. So I came across this on social media a couple of years ago, and it says America the Beautiful. And it basically talks about all the natural hazards that you see across the United States. So here we are with our hot air made of soup. So this past summer, just before the semester started, I went back to Texas to visit the family. I'm from this kind of area right between the hurricane terror area and the hot air made of soup. And pretty much every day I was in Southeast Texas, the temperature was about 35, 36 degrees Celsius. The humidity was about 70%. And literally you step out of the car and go into a shop and you're soaked in sweat. It's that gross. So nobody really likes living in this area during the months of June through about September because it's just too hot and humid. And then of course, the black area is at risk from hurricanes. If you are following the weather at the moment, there is a very rare Category 5 hurricane currently in the middle of the Gulf of Mexico, heading eastwards towards the west coast of Florida. That's going to cause a lot of problems over the next few days. So quite sad and scary that they've already had all the destruction from a hurricane just a few weeks ago, and now they're going to be dealing with something else as well. Then you get off to the western part of the U.S. where there aren't any tornadoes, and you think, okay, this is better, but obviously dealing with a lot of forest fires in this part of the world these days. I like the Seattle and Northwest Washington year-round depression because basically it's just cloudy and wet there all year long. Kind of like the British climate, really. And then you've got the ground moving here. My favorite is this, though, and I would agree with that. I would not want to live in the north central part of the United States. Literally, in the wintertime, temperatures in northern Minnesota can get down to minus 30 degrees Celsius, and you've just got snow and ice that are on the ground for months at a time. Has anybody ever been to Minneapolis, Minnesota? Basically, their whole downtown is connected by indoor walkways so that they never have to go outside in the wintertime. To be fair, they've just about done that in Houston now for the opposite reason. You can walk between most of the buildings in Houston in air-conditioned tunnels now as well. So lots of natural hazards in the U.S. Obviously, the tornado bit, what we're going to talk about for the next few minutes. But it does make you realize that the British climate, while is quite changeable and quite difficult to forecast for, it is quite a benign climate, and we are quite lucky that we don't have many significant natural disasters here. There are a few, like storm surges down the North Sea occasionally and big windstorms that can come through, but nothing on the scale of what we see across parts of the US from that perspective. So, I think I've probably already explained this, but why chase storms? That's a picture of me with a hailstone in my mouth. It became a bit of a tradition. I did it once as a joke, and now every time there's a hailstorm and I'm around it, I have to put one in my mouth. So basically, for me and for Kathy and Phil and Dan, we obviously enjoy the weather and we want to go out there and photograph it, and it gives us it's enjoyment. It gives us almost a little bit of adrenaline rush when you're out there and you see the clouds on the scale that they are, and you see the wind and that sort of thing, and the giant hailstones falling from the sky. There are people who go out there to actually do research as well, though. So this is the Doppler on wheels. So this is a mobile Doppler radar, which will try to get close to a tornado and actually inspect what the winds are doing in really high resolution right around the tornado. So I believe James, who talked to us before, James went to Reading, and as part of the degree at Reading, you can do a year in Oklahoma. You didn't do that though, did you, James? No. But so some students go from Reading and do a year of their degree in Oklahoma, and they get to work with some of these guys that do this sort of thing. This tornado actually is one that formed in Attica. Is that Kansas, Dan? Attica, Kansas? I thought you would know that. You know most of the geography. So the reason why I'm pointing that out is that there's another picture I'm going to show you from Attica in a minute as well. So basically, there's people that want to go out and see this stuff happening because it's sort of a hobby and it's interesting. There are people doing research. Unfortunately, there's more and more people that are going out there just to try to get a viral video, which is making storm chasing quite dangerous. One of the things that I found with storm chasing, both for tornadoes and hurricanes, is that if you're a biologist, for example, and you want to learn more about anatomy and that kind of thing, you can go into a laboratory and you can dissect animals and you can learn all about that sort of stuff. You can't really create weather in a classroom. So being out in the Great Plains where this happens on such an extreme, you can actually see things happening with the naked eye that you just don't see in Britain. And I remember taking Dan out the first time on his very first storm chase. You were still a student, weren't you? Was it just when you graduated, weren't you? It was your final year of your degree, wasn't it? Yeah. And so Dan's first comment before we even got to the Great Plains, we got off the plane in Houston, we drove to my parents' house, which is not too far from Houston. We got out of the car and he looked up and there was this cumulus cloud that was building and he's like, oh my God, you can actually see that moving because you can see these clouds bubbling up into the sky. That's how extreme it is. And you can watch a tiny little cumulus cloud grow from only maybe 1,000 feet deep to 50,000 feet deep over the course of 45 minutes. And it literally does look like a bomb's gone off and is rising up into the atmosphere. So that's partly what I like about the Great Plains, is just such a grand scale. So this picture here, this was, I think, somewhere in either northern Oklahoma. It might have been into southern Kansas, but we were watching a supercell that was about probably 20, 30 miles away from us at this point. And the reason I like this picture and show it is for this white wispy bit up here. So that white wispy bit in that cloud, or that picture, is called the anvil. It's the top of the thunderstorm. And in the Great Plains, these thunderstorms can rise to 50 or 60,000 feet above the surface. And I've got another interesting slide that I'll show in a minute about how that affects air travel. But obviously, you're getting moisture that's started at the surface and has been chunked up into the atmosphere over 10 miles up just by a thunderstorm. So pretty amazing to be able to see that sort of thing. This is a developing supercell, and the reason why I like to show this picture is because I'm reminded that when we were watching this develop, you could hear this constant sound. So obviously when you're kind of near a thunderstorm, you hear the rumbles of thunder. But when you're in the Great Plains and you've got these massive supercells, you can also hear this background rumbling. And you don't really notice it at first because you think maybe it's the wind or something, but it is a sort of low rumbling background noise. And actually, as that air is rising up into that storm at such an extreme rate, it's carrying with it pieces of ice up into the cloud. Then they're falling back down and bumping into other pieces of ice, and you can actually hear that ice bumping into each other, and it's called hail roar when you're out storm chasing. So it's this kind of background, kind of thundery sound that never ends until it all drops out of the cloud, obviously. This picture I included because really I kind of overdid the green on this in the processing, but in reality you can see a bit of aquamarine color in these clouds. And that's because as the sun is shining through the bits of the cloud that have a lot of ice in them, it causes this kind of greenish tint to the sky. So you know it's probably not a good idea to drive your car underneath that thunderstorm because it's probably got some large pieces of ice floating around in it. Mammatus cloud. So these thunderstorms are obviously, as I say, pumping a lot of moisture really high up into the atmosphere. And they get to the top of the atmosphere and they kind of almost bubble under, like you would think of boiling water kind of bubbling around, and you can get these beautiful mammatus clouds underneath the anvil of some of these thunderstorms. We saw some good ones of these rolling through Norwich a couple of weeks ago. I'm not sure if a week or two ago there were some nice pictures. They don't always have to form from severe thunderstorms, but that's where they're kind of most common. And then, of course, lots of lightning. This particular image was an interesting one. We were stopped at this car dealership. It was quite late at night. This thunderstorm was kind of moving over. It was producing very frequent lightning. That's one of the crazy things about storm chasing as well, is that when you get into the evening hours and the sun sets and these things are still going, they're producing many lightning flashes per second. So it literally for a while looks like a strobe light going off when you're near and underneath one of these. So we were sitting and trying to take some pictures of lightning. I had my camera on a tripod and I was just basically just clicking over and over and over because there was so much lightning. I thought I got this picture and I got really excited and I looked at the back of my camera and it was just solid white because the lightning had been so close and so bright that it just completely washed out the actual image itself. But when I put it back into like Lightroom or whatever on my computer, and I brought the exposure completely down to the lowest it would possibly go, then I was left with that image. So it's still a bit blurry around the main lightning strike, but that was probably only a mile or two away. I mean, the thunder was almost immediate after that lightning strike. A bit more of a safe distance away here. So this is a picture from just outside of Amarillo, Texas. Sun setting on the right-hand side, and that's one image showing two different cloud-to-ground lightning strikes. And that particular day had a real kind of purplish color to the sky, so it was pretty to look at. I'm going to talk a little bit more about the shape of this cloud in a minute. So this is lightning as well, but you notice that there's this kind of rounded shape to the cloud here. That's known as a mesocyclone. That is the base of a supercell thunderstorm. And I'll explain a little bit about those when I go into another slide or two, but that was in New Mexico with lightning coming out the bottom of it. And just, you know, nothing too crazy going on in this picture, but other than just amazing cloud structures. So, you know, again, if I see that in a day, even if I don't see a tornado, I feel pretty happy that I've been out there and seen such a beautiful cloud, basically. That's how much of a geek I am. But in all these photos, if you kind of notice, the landscape is flat, there aren't many trees, and that's what makes the Great Plains such a great place to go out and look for these thunderstorms, because you are looking at the entire horizon in 360, and you can be 20 miles away from a thunderstorm and still see the full structure of it. In fact, there are some storm chasers that like to get right up underneath the storm and get as close as they can to a tornado, but there's another set of storm chasers that actually like to be further back so that they can take these beautiful images of the whole thunderstorm themselves. So no matter how far away you are from one, if you see it, you probably get a good photo from it. Right. So this is kind of an obvious thing, but I've just wanted to kind of define a tornado before moving too much on from where we are now. So a tornado is defined as a violently rotating column of air from a cumulus cloud to the ground. So tornadoes can range from a few meters in diameter, sort of maybe the size of this room, to the biggest ones have been about 2.5 miles wide. They usually form from thunderstorms with very little warning. So that's different than something like a hurricane, obviously, because hurricanes are big storms that happen over the ocean, and we can actually warn people and get them evacuated sometimes a week in advance of before they make landfall. Tornadoes, we're talking about maybe 15 or 20 minutes warning time for. If it doesn't touch the ground, it's known as a funnel cloud. And tornadoes over water are called waterspouts. And wind speeds around tornadoes can be anywhere from about 70 miles an hour in a kind of weak tornado to the biggest ones producing winds over 200 miles an hour. So the fastest winds on Earth occur in the very largest tornadoes on Earth. And those have been mainly measured by weather radar that is estimating winds around a tornado. So weather radar has the ability to look at the speed of and the motion of a raindrop. And if you can see that this raindrop's going 100 miles an hour this way and this one's going 100 miles an hour that way, and they're right next to each other, then you can determine that there's probably winds of 200 miles an hour spinning around that tornado. I was bringing up Attica because this is still a sour point for me. This would have been my best tornado I ever saw. Those are two of my best buddies from uni who were out looking at that tornado, but unfortunately I wasn't able to go out that day as I had another commitment that I had to go to, so I missed out on that very photogenic tornado. Right, so when do these things occur through the year? Well, basically, there is a specific season in the Great Plains for tornadoes, and that typically is in the springtime. So there is a very definite peak in tornadic activity through April, May, and June. And so this image here is showing you the tornado probability for the 15th of May, and you can see that it's kind of centered around the state of Oklahoma, right in the southern Great Plains. As the year progresses and the temperatures start to warm up, this zone will shift further north, and in the winter, the zone shifts further south. But actually, in the southeast, where we talked about there being more deaths from tornadoes, the season kind of goes on all year. There's a little bit less of a peak than there is in the Great Plains, but you actually can see that you still have a fairly, well, these are small risks, really, of a tornado occurring within a few miles of your house. So this is the probability of a large tornado within 25 miles of your location. And the percentages here, even in this darker shade here, are only 0.35%. So there are plenty of people who live out in the Great Plains of the US and have never had their house destroyed by a tornado. They are still relatively small given the size of the landmass that they're affecting. And the last point that I should mention before I move on here is that most of these tornadoes occur from supercell thunderstorms that I'll say more about in a minute. But they're most common in the late afternoon and early evening for the same reason that we get our thunderstorms mostly in the afternoon and evening. You need the heating of the day to warm up the land. And for those of you who are in the second year module, this past week, Ben's been talking to you a little bit about that, and we're going to have a practical later this week where we plot a tephigram, and we're going to look at the fact that air rises as it warms up over the land, and that creates more instability in some cases, and that's when thunderstorms occur. So just a slightly different way to visualize this. On the left-hand side here is a graph from Lubbock, Texas, which is basically in the southern part of the Great Plains. In Tornado Alley, and on the right-hand side is a city in Mississippi called Hattiesburg, and this is showing you the tornadic probability through different dates of the year. And you can see that in the Great Plains on the left, there is that distinct spike that happens pretty much in early May. But elsewhere in the year, if you get outside of the spring months, tornadic activity is relatively small. But in Mississippi, there's a peak in the springtime, and there's generally another peak in the autumn as well. And so I chased a storm that basically destroyed my partner's university in Mississippi back when we were there in 2003 or 4. It was an EF3 tornado that went through this town and pretty much wrecked the entire university for a couple of weeks. But that occurred in late November. Right, moving on to what do you need to take with you when you storm chase. So I've got a few slides on if you're going storm chasing, what do you need with you? The first thing is probably a reliable vehicle. Stupidly, whenever I've chased in the past, my mom lets me borrow her car. She's not a dummy though. She actually knows that the biggest risk in storm chasing isn't getting killed by a tornado. It's probably getting your car completely destroyed by large hailstones. And for those of you who might know who Reed Timmer is, he's one of the more famous storm chasers out there. And I'm going to steal one of his videos toward the end of this talk and show you a big tornado that he got close to. But I think I saw in the last week where Reed's been banned from renting cars in the United States now across all rental companies because they're tired of him returning them looking like this. So this isn't actually my car, thankfully. This was parked in a car park after I was storm chasing one day, and I took a picture of it because obviously they had been under quite a large hailstorm and got their car beat up. Some people, though, will actually mount complete weather stations on top of their vehicle. You don't really need to do that to storm chase. You can get plenty of data elsewhere. You don't need to collect it yourself, but you can see some interesting micrometeorology around these storms. So there's parts of the kind of western part of the Great Plains where there's something called the dry line. And it's basically a front between the dry desert air to the southwest of the US and the warm, moist Gulf of Mexico air that's coming up from the south. And you can drive across this line that's literally, you can go 2 or 3 miles and the humidity will go from 70 or 80% to about 10% over like a 10-mile distance. And actually, it can be sunny on both sides of it. But the sky looks completely different. When you're in the humid air, the blue sky has this kind of hazy white look to it because of all the humidity. And then you go to the other side where it's dry and the sky is just bright blue. And you can do this before the storms start to erupt during the day. And usually those storms will form near the dry line. So it's a good place to kind of hang out in the morning before before afternoon thunderstorms. So what else do you want to take with you when you storm chase? A glamorous picture of me. But this is a picture, one of my buddy's pictures of basically mounting cameras in your car, putting laptops in your car. There's Dan in the back looking about 15 years old. So basically, when I go storm chasing, I like it to be at least a team of 3 people. You have the driver, and honestly, that's probably the most important job of the storm chase, is that you're driving through some pretty horrid weather conditions at times. After these storms pass, you can often drive through hours of just heavy rain and lightning to get to your hotel in the evening. So you've got to be aware, and you've got to be not distracted. So you've got to take that part very seriously. And then usually the person sitting next to you is kind of helping with the navigation and kind of deciding where to go, looking at the kind of radar and saying, okay, well, we need to get here from here, and and kind of plotting out the path, and then shouting at the driver to do what they say. And then you got the person in the back here who's doing all the real weather forecasting, like I was on this particular day. Not really. I probably just had a bag of donuts. But in the back seat, literally you could do a full-blown weather forecast from the back seat of a car on the interstate in the United States. You get good internet connection. You can go through all the websites, and the same stuff I would sit and do at WeatherQuest, I could technically do from the back seat of my car if somebody else was driving on a storm chase. So you've got this rotation of people that you kind of change jobs every day to keep it interesting. It's one of the few places you still can have fun using an old school map as well. Particularly if you get out into like Oklahoma and Kansas, there's a ton of dirt roads and clay roads that don't show up on a sat nav. And you can buy these gazetteers, which are like this thick, and they show you every little farmer's road that you're technically allowed to drive down. I have learned a couple of lessons there. We did put a van in a ditch and had to pay a farmer $100 to pull us out one day because we drove down this red clay road, and then a bunch of rain happened and the van just slid straight off the road. So, and then this is a picture from my buddy Pete, who's a kind of very experienced storm chaser, and all the stuff that he takes with him when he goes. One of the things that he has as well is something called a lightning trigger. So you can connect this to a DSLR camera, and instead of clicking the shutter every 2 seconds trying to take a picture of lightning, it will actually look for the flash and open the shutter immediately, and you can kind of cheat and get lightning pictures that way. So he takes that amongst all of his cameras and that sort of thing. Another thing that's very important to have with you is the NOAA weather radio. So that's what you're seeing on the left-hand side there. And then there is an app or a platform you can subscribe to called RadarScope. There are other very similar things available out there as well, but this allows you to get the live radar data, and you can plot your location where you are compared to the storm. But that weather radio actually has a much more important role. And if you live in the Great Plains of the US, or really anywhere where severe weather can occur, you can buy one of these weather radios and you can put it in your house on standby with batteries. And it's probably as important as a smoke detector in your house, because if a severe weather warning is issued by the Weather Service, a massive alarm will sound on this radio. You can turn it on and you will get instructions. And right at the very end, I'm just going to let you hear one of those warnings and tell you a little story about a place called Greensburg, Kansas. My mom has a weather radio in her house, and every time it goes off, she panics and calls me and asks me what's going on, rather than to listen to the message, which would tell her everything she needs to know. Another thing that you would need if you're going out storm chasing is to probably pay attention to the Storm Prediction Center website. So the SPC is the main national body that forecasts severe weather in the US. They're responsible for all severe weather watches that get issued. So SVR means severe thunderstorm watches, TOR means tornado watches. So they will issue those on the days where there's severe weather that's likely. And they also write a lot of discussion about the weather as well. So if you're on the road storm chasing, reading those is really valuable because very experienced severe weather forecasters are writing them. And in the US, we have lots of local weather offices scattered around the country. And so if a tornado warning is actually issued for your location, it will be issued by one of your local weather offices. Again, it will sound that weather radio, and it will go on the TV and across the radio and on text message alerts and that sort of thing to everyone who's in the path of that. Right, time is getting on. I don't want to take up too much more time, but I do want to go on a little 3 or 4 minute sidetrack, because basically chasing tornadoes in reality is not like the movie Twister, where it looks like there's a tornado every day they're out there. Most of the time, you're going to have at least a couple of down days on your storm chase where there isn't any severe weather. So I'm going to show you 3 places that I like to go whenever that happens, and they're all around Amarillo, Texas, so northern Texas, and one of them is Cadillac Ranch. So basically, this is an old farmer who's unfortunately passed away. I think his son still owns the land though, but he was into modern art. He decided that he was going to basically buy a bunch of old Cadillacs and bury them nose down in his field. And so this is basically our Texan Stonehenge. So you've got like a dozen Cadillacs buried nose down. The field is open to the general public. People can go spray paint all over them. I loved it being there on this particular day though, because there was obviously a storm chaser there just before me who had spray painted F5 on the Cadillac there. So the other thing to say about storm chasing is that you are in a car with people for 2 weeks potentially. So bringing along people that you get along with is quite important as well. And if you go on a trip with just a tour group, you might be stuck with people that you'd rather not be. So I like to go out there, and that's a group of friends. There are a couple of English people that went with me on that chase as well back in the day. Another place that you can go is Palo Duro Canyon. So this is actually the second largest canyon in the United States, and it's in north central Texas. You can actually drive down into this canyon and camp and hike and all that sort of stuff. But there are loads of signs anywhere you get out of the car saying that if you don't have liters of water with you in the summer, you might die within an hour of being outside because it gets so hot down in the canyon. And every type of poisonous animal you can imagine lives in that canyon as well. So we've got scorpions, spiders, snakes, and they're all poisonous down there. So that was a dead rattlesnake on the side of the road that we saw on one of our trips. So you can see we weren't storm chasing that particular day. It was quite a nice day. But my favorite place to go when I'm in the Great Plains, I got a reputation for liking food at WeatherQuest, so that's why all my colleagues are laughing. So this is the Big Texan Steakhouse. You know this place must be important in the Great Plains because any road that you travel toward Amarillo on, there are huge yellow billboards on the side of the road that say free 72-ounce steak ahead. There is a little asterisk next to a little star next to the free though, because there are some terms and conditions. You have to eat this 72-ounce steak, a baked potato, a dinner roll, a side salad, and a large glass of iced tea in an hour while you sit up on a stage in front of the rest of the restaurant with a clock in front of you and a webcam pointing at you. You've got to do it all in an hour, and you can have the steak for free. If you don't do it in an hour, then you have to pay them something like $70 or something like that. So that's a pretty big baked potato wrapped in foil in the background there, just to give you an idea of how big this steak is. I have had a friend who tried it, and I'm not going to get into the details, but it wasn't pretty for him at the end. He actually told me afterwards that the worst part of trying that wasn't actually how full he got. It was the fact that his jaw was sore for days because he was trying to chew the meat so fast. I think the people who actually do it pretty much get it cooked rare, and they just swallow pieces of meat. Anyway. There's a sign next to the door that tells you who all have done it, how much they weigh, how old they are, where they're from, and they can leave a little comment. And in the comment section, a few of those said, "What's for dessert?" Apparently, there was a very small framed lady who went in there and ate 2 of those in an hour. So pretty amazing stuff. The other thing, just quickly about the Big Texan, the very first time I went there, I went with some chasers who had been chasing before me a few times, and they told me that I was going to be really excited because the Big Texan had a storm chasing museum. And so I was like, yeah, that'll be cool. So we get to the Big Texan, and actually their storm chasing museum is some tornado wreckage from a previous tornado in Amarillo where they had dumped it in the car park and put a fence around it, and they just hung a sign that said it was the storm chasing museum. So that was a bit of a letdown. Right. Last few slides, and then happy to take some questions. So I'm going to show some video as well and tell you that story about Greensburg. But really, this is the map that kind of explains why the US is so unique in the world from the perspective of severe thunderstorms. So there are a few different things going on in this map. So we've got Tornado Alley, the red bit here. You've got this green blob that's called warm moist air. So this is the Gulf of Mexico. It's one of the warmest bodies of water in the world in the summertime. Temperature in the ocean water can get above 90 degrees Fahrenheit, which is mid-30s in Celsius. The water temperature does. So as a kid, I grew up about right here. We would go and rent a beach cabin for the week, and we would go and get in the sea at night, and the sea temperature was warmer than the air temperature, so it was like you were sitting in a warm bath. The reason I'm telling you this, especially for you students, is that the warmer your air is, the more water vapor it can hold. So if you've got warm air and you've got a hugely warm water source, you can pump a ton of humidity into the atmosphere, a lot of water vapor into the atmosphere. And if you get low pressure here and air flowing around low pressure like this, it drags all that warm, humid air up into the Great Plains, somewhere that it shouldn't really be. And so that's the first ingredient and possibly the most important. The second ingredient is in the springtime, still snow over the Rocky Mountains in Canada. So again, if your air is circulating around the low like this, it's pulling down cold air from the Canadian Rockies. And there are days in the spring where Amarillo, Texas, which is about here, can have a day where the temperature makes it to about 35 degrees Celsius, and then the next day there can be snow on the ground. That's how large of a temperature contrast can happen in the springtime in that part of the world. So think about our entire annual range of temperature that we get here happening in 24, 48 hours in that part of the world. So cold air, very dry, very dense, warm air, moist and less dense. As cold air pushes into the warm air, basically acts like a bulldozer and forces it up in the sky. So if you force a bunch of warm, moist air up into a sky that's colder, what happens? Huge clouds happen, and then if you have other stuff going on, potentially huge thunderstorms. So what is that other stuff? Well, one of the things is you've got a strong jet stream blowing across where you've got this area of low pressure developing. So you've got these really strong winds in the upper atmosphere. And you're also dragging in some dry air from the desert southwest of the US. And actually, this bit of air right here might be what makes the Great Plains so unique in the world in terms of severe weather. Because what happens is the desert out here in this part of the US is actually quite elevated. It's quite high in elevation. So you've got probably 6,000 to 7,000 feet of elevation there. And as those westerly winds pull that dry air into the Great Plains, what happens is it moves out over the warm, moist air that's underneath it. So as that warm, moist air starts to rise, it encounters a layer of warm, dry air above it, and it can't rise anymore. So basically, it gets trapped under there until more warm, moist air builds up underneath it, and basically, it sort of pressure cooks that air, just adds more and more moisture and heat underneath it until it gets strong enough to break through that dry air and explode into the atmosphere. And that's what's known as the cap. So if you do storm chasing and follow severe weather, you'll hear about the cap breaking, and the cap is provided by this warm, dry air that pulls out into the Great Plains above that warm, moist air. So you've got air moving from all different directions, different speeds, different types of air masses colliding in a really grand scale across the Great Plains, and that's what actually produces these big thunderstorms. They actually are called supercell thunderstorms when you've got all this wind shear going on. So they form in very unstable air with significant wind shear. These particular thunderstorms can last for hours and they can move for hundreds of miles, and I've got a slide that'll hopefully explain that in a minute, and they almost always produce severe weather. And I'll explain what that means as well. This is that map I was showing you, or talking to you about. So these are airplanes flying across the US at 2 a.m. our time, so that must have been sort of 8 p.m. Across the US back in April 2016. This is a line of severe thunderstorms that extends from southern Nebraska all the way down into South Texas, almost Fort Stockton, Dan. So you can see, though, that the height of these thunderstorms mean that the plane can't fly through them. They have to fly around them. So if you're taking off on a flight from, say, Memphis, Tennessee, and you want to go to Denver, Colorado, your plane's going all the way up here around that to get back to the airport in Denver. So they have a significant impact on air travel as well, because you can't fly over them. Right, I hope this works. This is possibly the oldest slide I've got in my deck now. I should give Dan Hulley credit. He did create this. He was inspired by Paul Knightley, though, for Phil and Kathy, who probably know Paul. So I'm going to basically just quickly talk to you about the development of thunderstorms. So you've got warm air that's rising. As that warm air rises, it will cool and condense into a cloud. As that warm air rises, it creates a sort of lack of warm air here as you've got lower pressure. So the air will move in from either side, converge and continue to rise. As the air gets to the top of the cloud, it cools. That cool air will sink back down through the cloud, and it's dragged back down to the surface by rain. And eventually, the rain will come out of that cloud, the cool air will move away from the thunderstorm, and all the energy supply to the thunderstorm is gone now. And so eventually, that whole process will decay. So this is known as a single cell thunderstorm. This is a typical thunderstorm in the summertime in Britain when we have light winds. So you can go from kind of clear sky, sunny skies in the morning, thunderstorm pops up, rains heavily for a few minutes, might get a couple of rumbles of thunder, and then 30 minutes later it's sunny again. And these are quite typical storms where I grew up in Texas as well, because there's not much wind shear. Now, in the Great Plains, there is a lot more going on. So you still have your warm air that's rising, you still have your air that's converging, but now we're talking about strong jet stream winds, so very fast winds moving across the top of the storm. And as you go toward the surface, the winds are moving less fast. So there is a wind shear that is a speed shear that's created with less winds down near the surface, or lighter winds near the surface and stronger winds aloft. So that starts to basically tilt your storm over on its side, which we didn't do as a schematic. But also, near the surface, we've got usually, if you've got low pressure, say you've got low pressure here, you've got air flowing in from the southeast down near the ground, but over the top of that, you've got air flowing from the west, from the jet stream. So you have this directional wind shear as well. You have these south or southeasterly winds near the surface, bringing air off the Gulf of Mexico, and you've got these strong westerly winds up in the atmosphere associated with the jet stream. So you've got what we call speed shear and directional shear, and that's what starts to get the storm to rotate. So those mesocyclones, those weird kind of flying saucer-shaped clouds, start to develop due to this whole thunderstorm beginning to rotate because of all this wind shear. And then eventually, as the storm is rotating and air is moving up through it, it can grab some of that spin that's happening in the storm and stretch it vertically into a faster, violently rotating column of air, and it can push it to the ground as a tornado. And then that's what happens. But the other key to these storms, I think, will be easier to explain in this time lapse that I'm going to show next. So I'm going to move on from that. I need to just quickly say that, remember the weather radio that I mentioned? It will go off if one of three things is happening. If hail is being produced that's greater than 1 inch in diameter, winds are greater than 58 miles an hour, or a tornado. Doesn't matter how much lightning is being generated, that won't trigger a warning. But if any of those other three things happen, then you've got a severe weather warning that's being issued by the National Weather Service. So I just need to stop the laser pointer here. And now I'm going to play this video. So this is from my friend Pete. This is a supercell thunderstorm. in Texas several years back, and there's a couple of things I'm going to pause the video and point out before I finish playing it. One is that you'll notice in this video there isn't really a flying saucer shape to things yet, is there? It's just a sort of black, it's not a great resolution of the screen, but what you notice here is that you've got this dark base of a cloud here, and then you've got this heavy rain where you can't see the base of the cloud. So what's happening here is that as this thunderstorm is developing, air is being sucked into this part of the storm here at such a rate that rain can't fall back down through it. So you've got a rain-free base, and then all the rain is being sheared by those stronger winds aloft over to this side of the storm and then falling out of the cloud on this side. So you've got very heavy rain and hail happening here, and you've got air rising into the storm like a vacuum cleaner on this side. And what makes this video so awesome is that there was actually a grass fire occurring on this particular day. So there was a lot of smoke being generated at the surface, and you can actually see what the air is doing around this thunderstorm due to the smoke. So if I play the video, you can see that smoke basically being ingested into the base of the thunderstorm. So it's going along the surface, and then it gets to the base of the storm and it's being whooshed up into it. And it's pretty amazing to be able to see that in reality, because that's happening around every supercell. You just never get to see it normally. But as that plays on, you can continue to see that that rain-free base is there and that very heavy rain. I mean, rain rates in this would have been ridiculous, heavier than any rain we've ever seen in this country, probably. And I'm going to just fast forward this because it does go on for a minute or two, just so you can see what it looks like a little further on. At this stage, you can now start to see a bit of rotation, and you can also see that mesocyclone becoming more visual now, that kind of flying saucer shape to the storm. Pete then kind of pans around and shows that actually away from this thunderstorm, as the cold air moves out away from it, it creates this long gust front as well, which is quite pretty to look at. And then, so here is the low pressure, the mesocyclone. Here's all the heavy rain being kind of thrown off into the distance and going off. And actually, I think there was even another supercell further up the shot there as well. So he comes back, and I'm just going to play this a little bit longer because this storm does get very pretty. So this has been sped up about 4 or 5 times faster than the naked eye would see it. But you can start to really see the whole rotation. These are tiny areas of low pressure. So they're mesocyclones, meso-low pressure areas, only maybe 5-10 miles wide and rotating around. And what you're seeing here is another interesting phenomena. A lot of people who don't know much about weather will start calling in a tornado here. What's happening right now is that all that rain and all that moisture is hitting the ground and being hoovered back up into the storm. And when you have increased humidity, your cloud base lowers. So you've got lowering pressure and increasing humidity, and basically your cloud starts to develop closer and closer toward the ground here. So basically, you get these kind of what look like tail clouds sticking out of the base of the mesocyclone, and a lot of people will think that's a tornado, but actually there's no spinning air there. It's actually air that's being sucked up into the storm. The only disappointment with this video for me is that there wasn't a classic tornado with it, but if you watch over here on the left-hand side, when I hit play again, there is a lot of dust and debris being kicked up underneath the storm there. It is possible that there was a brief tornado that didn't have a traditional sort of condensation funnel that you could see the actual funnel coming down, but you see the bits of air and debris. It's hard to know whether that was outflow winds that were coming out of the storm or whether that was a spin-up that happened. But I often think what the kind of Native Americans must have thought when they saw these things drifting around in the Great Plains as they were chasing their buffalo. They must have thought that was some crazy yes going on. But yeah, just watch this play out because Pete and the guys let this get up right over the top of them. So the last image on this video is really nuts.
Nice, like, look. behind you. And
So there's another one further down the way, another supercell that's several miles further away. Right, a few videos to end. We are almost there. I was just going to play this video. Dan was with me for these next couple of videos, I think. So this one was a thunderstorm about 15 miles off to the right-hand side of the screen. That cold air coming out of that thunderstorm, moving away from the storm, and producing wind gusts of 50 to 60 miles per hour, bringing debris with it. We stupidly drove under power lines with the winds blowing about 50 or 60 miles an hour and hardly any visibility. There were tiny bits of twigs and stuff flying around. I think we did give my mom's car a good wash after that. But if I remember correctly, there was like dust coming through the air vents and stuff as well. You could like taste it in your mouth. There was so much of it getting into the car. It was quite crazy. Then this storm was also warned for, and this was warned for hail. So pay particular attention to the grassy area here where the hailstones bounce off the grass. You can kind of get an idea of how big they are. Some of them were definitely bigger than golf balls and probably getting closer to the size of a tennis ball. One or two of them were. The more I watch this, the bigger pieces I see occasionally falling out of there. Let's see if I can turn this up a bit. Very loud and powerful as well. So the story with that particular storm is that we saw it coming, so we drove to the nearest town that was in the path of it, and we asked the hotel concierge guy if we could leave our car underneath the little drop-off area where there was an awning. And he told us thank you and went and got his car and parked it behind us and sat and watched the storm with us as it came through. But yeah, I think it did cause some hail damage in the town afterwards. The next video is the closest I've ever been to a tornado and one of my few that I've ever seen. So my buddy Greg, this was back in the early days and we hadn't seen much weather in these days. So he put this video to storm chasing music and sounds overly dramatic. But basically we punched the western side of the storm through a bunch of hail and strong winds and heavy rain and busted out with the tornado right in front of us. It's not the way you're supposed to do it. We chased it in from the west. You should really stay south of a storm. There's actually a little bit of a saying in storm chasing, an acronym of ASS, A-S-S, always stay south. But we came in from the west and then the thing was right in front of us. And I actually got kind of scared with this one and we turned around the car at one point. But I'll fast forward it a little bit. I had to beep out some language as well because I show this to kids sometimes. Greg has a potty mouth.
God, we're right under it. No, we're not under it yet. We still got. Look right above. That's the mesocyclone. That's the rotating wall cloud. That's what I meant. We're under the mesocyclone. All right, man. It's on the ground. It is on the ground. Slow down. Slow down. Slow down. Slow down. Slow down. Slow down. Whoa, debris.
It does show up in a second.
Power flashes. Hold on. Stop. We got power flashes.
So this thing was kind of very erratic, going up and down, and eventually turning into like a multi-vortex tornado right in front of us. It was only a couple hundred yards away at one point.
It's like 100 yards in front of us. We are safe. Can you hear me?
We were talking back and forth to each other on CBs.
All right, back up a little. Back up.
So when Greg got scared, I did, because he never gets scared about anything. But we followed it on for a few miles. It kept doing that sort of thing. We did let it get further ahead of us, and eventually it kind of got wrapped in the rain and we couldn't see it anymore. But that was a very small tornado, like an EF0 or EF1 tornado. So I've never seen one of these before, but I'm going to show you a much larger tornado, this video by Reed Timmer. This video is insane because he drives towards it. He's got a zoom lens, so he's quite far away from it still. But the reason why it's quite cool is because you see the telephone poles? Eventually, he's going to drive down this road and you're going to see one snapped in half and the other half of it in the field. And then beyond that, no more telephone poles. So God knows how far away they got slung by the tornado. But I'll turn this up so you can hear it as well, because he stops the car and gets out, and you can really hear the wind when he does that. There's the snapped in half telephone pole. So that was the Dodge City, Kansas tornado. Do you remember what EF that got? Anybody in the room? Was it EF4? Yeah, you were chasing. Well, you didn't quite get there in time, did you? Yeah. So luckily, yeah. Luckily, most of those tornadoes that day did stay out over open farmland. It didn't cause too much damage, but just kind of shows you you saw near the surface how fast the wind was rotating around that thing. So this is it. My final slide, basically. I want to let you listen to a warning. So I want you to just picture yourself. You live in Kansas, probably about 10 to 12 times a year. Your area is under a tornado watch, which means that conditions are favorable for tornadoes, but it doesn't mean the thunderstorms developed. So most of the time you hear some other town was under a warning, or maybe you were, but no tornado actually came through your town. So it was about 9 p.m. in the evening, so people getting ready for bed, watching the evening news, blah, blah, blah. They would have known that there was a tornado watch out for the area. This particular tornado was an EF5, so it was one of the top 50 strongest tornadoes that we've ever recorded in U.S. history, probably even in the top half of that realistically. It was a large wedge tornado. It was at night, so nobody really saw it apart from this picture, a couple of pictures like this where lightning was flashing and you could get the silhouette of the tornado in the distance. So it was about 2 miles wide, so one of the widest tornadoes ever recorded at the time. The town had about 3,000 people in it, and it's very sad that 12 people died, but it is amazing when I show you the next picture after this. I'm going to show you what it looked like after the tornado went through. It's absolutely astonishing that only 12 people died from this, and that's partly due to the fact that there was a warning that was issued about 15 or 20 minutes beforehand, and if you live in Kansas, you take the weather seriously, so if a weather warning happens, you actually do know what you're going to do, and you listen to it and you do it. It leveled 95% of the buildings in the town, and as I say, there was about a 20-minute lead time. So this is what your weather radio, I should have put what it sounds like when it goes off because it's kind of eerie, but you hear the warning and then you turn your weather radio on and you would have gotten this advice from the Weather Service.
The National Weather Service in Dodge City has issued a tornado warning for Cuyahoga County in south central Kansas until 10 p.m. Central Daylight Time. At 9:17 p.m. Central Daylight Time, National Weather Service meteorologists were tracking a confirmed large and extremely dangerous tornado 14 miles south of Greensburg, or 11 miles northwest of Wilmore, moving northeast at 25 miles an hour. Locations impacted include Greensburg and rural residences of eastern Cuyahoga County. This includes Highway 54 between mile markers 105 and 115. This storm has a history of producing tornadoes causing damage. The safest place to be during a tornado is in a basement. If at a mobile home, evacuate to a substantial structure. Get under a workbench or other piece of sturdy furniture. If no basement is available, seek shelter on the lowest floor of the building in an interior hallway or room such as a closet. Use blankets or pillows to cover your body and always stay away from windows. This is an extremely dangerous and life-threatening situation. A large tornado has been confirmed. If you are in the path of this destructive tornado, take cover immediately in a basement or other underground shelter and get under something sturdy.
So that particular warning would have just gone off on repeat for the whole time that that tornado was approaching that town. And it would have been on the TV, on the radio. Back then, they weren't giving text messages, but nowadays you'd have got an alert message on your phone that would have been pushed out as well. The picture I'm going to show you next was a couple of days after the tornado. But every bit of damage you're going to see in this picture was done in probably less than a minute. And it was a few days later, and I only know that because you can see that they've basically cleared paths in the road so that they could do a search and rescue for people. But that's what the place looked like. So there were trees in that town. You can see the trees sticking up. Not a single leaf or small branch left on the trees. They were just completely sucked off the trees. And they basically, most of these houses, especially through this part of the town here, were just completely destroyed. They found photos and people's personal documents 50 miles away from that town. That's how far the thunderstorm carried them downwind. But there is some interesting stories about Greensburg. There's been a documentary made about how when they rebuilt the town, they did it with a lot of recycled material from all the damage, and they've made it a very green town. So they made something good out of it. I think about 2/3 of the town's population returned, and the rest of them just probably went and built houses elsewhere. But kind of a sombering note to end on there. But that is where I'm going to finish. But I'm happy to answer any questions if anybody's got any. Thanks for your time. Does anybody got a question? Marcus?
Do you know if there are any sort of insurance type policies that, not necessarily townsfolk, but also farmers, if a tornado, completely strips their food or something?
Yeah.
Is there insurance?
Yeah, there is. I mean, most farmers will have insurance, particularly covering hail damage in the Great Plains. And one of the other interesting things you see out there is car dealerships that are out in the Great Plains. In the US, a car dealership usually has all their stock at their location. And so these car dealerships will have awnings over all their cars because of potential hail damage. So you can get insurance for weather, for tornadoes and hail in the Great Plains. The premium is higher than it would be elsewhere in the world. But you saw the tornado probabilities there. It's still very, very, very small chance that your house is going to get destroyed by a tornado. More of a risk of getting, damaged by hail. But you can get it. And I would imagine most farmers have, most of the farms out there are now big industrial farms anyway. I don't even think people ride on their combines anymore out there. It's all computerized stuff. So, any other questions? Yeah, Zach?
When a tornado touches down, how predictable is it to sort of track?
Yeah, that's a very good question. There's so much when you start putting a talk like this together that you kind of skip because you realize I could go on and talk about this for probably 4 hours, but you'd all be asleep. So basically, before a severe weather event what the wind speeds are generally doing in the middle layers of the atmosphere. And so in the forecast leading up to that particular day, there are often mentions of what the storm motion will be that particular day. So it'll say storm motion today will be southwesterly at 35 miles per hour. So meaning that basically these storms are tracking at 35 miles an hour from the southwest. And so once the tornado is formed, they typically will move at the speed of the thunderstorm. So their forward speed can be anywhere from as little as some tornadoes, especially later in the season, up in the further northern part of the Great Plains, will actually just sit in the same place for 30 minutes and you can just watch one and it's not moving at all. It's just grinding over the same area. But others, particularly earlier in the season and further south, can move at 50, 60 miles an hour with a forward motion. So if you've got winds here doing 150 miles an hour and the storm progressing forward at 50 miles an hour, then you've got an effective forward speed of 200 miles an hour around one side of that tornado. So generally you do kind of have an idea, and they do generally follow a similar track, supercell tornadoes. There are a few that can be erratic, but most of them will travel from southwest to northeast through their life cycle. So that's generally how it works. Anyone else? Marcus again? You can just ask me in the office, Marcus.
In the UK, obviously, we have like the thunderstorms, they bubble up, and you can see a line that thunderstorms generate. Is that something that these sort of storms do result, or is it quite sort of simultaneous along that line?
No, that's a really good question. And actually, I mentioned the dry line. There are some very classic days when the dry line is very defined, where you'll get a supercell develop, and then another one, and then another one, and then you can have a whole line of like 10 supercells that span over about 1,000 miles. And generally, they're quite discrete storms at first. So there's an individual supercell, and then there's a gap between them, and then there's another individual supercell. But as the day wears on, the rain wraps around most of these, and they tend to congeal into these very large areas of heavy rain and lightning, and they're called mesoscale convective systems, MCSs. And so you'll start chasing and looking at these very pretty single event thunderstorms, but then when you finish the chase, it's just this huge line of rain that you can't avoid, and you're going to get run over by it wherever you end up finishing your chase day. So many of us who have chased know that you get to your hotel and you actually have hours of lightning to watch, usually at the end of the night, as these things kind of disappear slowly into the distance. So, no questions from the students? All right, well, I'm gonna be with you guys on Thursday in a practical, and I'm gonna expect at least one question from you. So for those of you who are here, think of something to ask me on Thursday. But I'll hand it back to James now. He'll tell you a few things, but thank you very much for your time.